Hi everyone, I am Saimani and today I will be presenting a topic on autocomplete TextView in Android. This video will cover what autocomplete TextView is, how it works, and why it is useful in Android application development. I will also walk you through a practical demo in Android Studio and finally conclude its real-world applications and future scope. So let's get started. Before we dive into the details, let me give you an overview of what we will cover in today's presentation. First, we will look at the core concepts and functionality of autocomplete TextView. And next, we will understand the implementation architecture and how it fits into Android application. Then I will give you a hands-on code demonstration in Android Studio. And at last, finally, we will explore some real-world applications where this feature is commonly used. By the end of this session, you will clearly understand how to implement autocomplete text view in your own Android projects, and much more importantly, you will see how it can enhance user experience by providing intelligent text suggestions and also making data entry faster and more efficient. Now let's talk about autocomplete text view. Autocomplete text view is a very useful Android UI component that provides real-time text suggestions as users type. This helps in improving both user experience and input efficiency because people don't have to type everything manually. It also comes with some key features. Firstly, it offers dynamic suggestions, meaning it displays relevant options based on what user is typing. This happens instantly and in real time. Secondly, it has a customizable threshold, which means that we can configure how many characters a user must type before the sessions start appearing. And third, it supports adapter integration. So it works smoothly with array adapter as well as some custom adapters also, giving developers flexibility. On the right, you can see an example. As a user starts typing in the search bar, it immediately shows city name suggestions like New York, New Delhi, or Newcastle. So overall, autocomplete text view is a powerful way to make user input faster and more accurate. Now let's see how an autocomplete text view actually works. The process begins with the user input. As soon as the user starts typing in the text field, the component captures the input. Next, this input goes through the adapter processing. This adapter acts as a bridge between the data source and the UI. It checks the dataset, whether it's an array, database, or a custom list, and prepares it for filtering. Then comes the suggestion filtering. Here, the system compares the user typed text with the available dataset and filters out only the most relevant matches. After that, we have the drop-down display. The filter suggestions are shown in the drop-down menu directly below the text field. So what happens is the user can quickly see all the possible matches. And finally, we reach the user selection. The user can simply tap on one of the suggested options and it automatically fills into the text field. This saves time and improves accuracy. So in short, autocomplete text view follows a very structured flow from user input to adapter processing, filtering, drop-down display, and finally selection, making both text entry faster and smarter. Let's now look at the key features and components that make this autocomplete text view so effective. The first one is the threshold control. This allows us to decide after how many characters the suggestion should start appearing. Usually, it is set to 1 or 3 characters. This helps strike a good balance between the performance and user experience because the suggestions won't pop up too early or too late. Next, we have the adapter integration. The adapter is what that connects the data source to the autocomplete text view. It can be a simple array adapter if we are working with a small list, or a custom adapter if we want more control over the filtering logic and control how data is displayed. And finally, the drop-down UI. This is the visual part that the user interacts with. The drop-down presents suggestions in a clean, scrollable list, and developers can even customize its styling to match the app's design. So these three threshold control, adapter integration, and drop-down UI work together to deliver a smooth and efficient autocomplete experience. Now let's look at the key properties and methods of the autocomplete text view. Starting with the XML attributes on the left side, the completion threshold attribute let us define the minimum number of characters a user has to type before these sessions appear. For example, here it is set to 2, meaning that the drop-down will show after 2 characters. The completion hint is simply a little hint text that appears, encouraging the user to start typing. Then we have the drop-down height and the drop-down width attributes. These control the size of the sessions box. For instance, you can make it as tall as 200 dp or span the full width of the screen with match parent. And finally, the pop-up background. allows us to style down the drop down visually, like setting a custom background by keeping the image in the drawable folder. So these example attributes mainly define the appearance and behavior of the sessions dropdown. Now moving to the Kotlin methods on the right hand side, the set threshold method does the same thing as the XML threshold, but this is done through programmatically. The set adapter is crucial because this binds our data source, basically the list of items that we want to suggest. Then the set on it item click listener. This lets us capture what the user selects from the dropdown so that we can take action based on that. We also have the methods like dismiss dropdown to hide the sessions and show dropdown to make it appear on demand. And finally, the getString.toString method. This is used to retrieve the actual text that the user has typed or selected. So in short, XML attributes handle the layout and styling, while the Kotlin methods give us the programmatic control over user interactions, data binding, and dropdown behavior. Here's a quick overview of the implementation. First, in the XML layout, we design the user interface with the autocomplete text view and apply the necessary styling to it. Then in the Kotlin file, we connect it to a data source using an array adapter, set the threshold, and handle item selectors with listeners. Finally, we will do the testing and validation by typing live, checking sessions, and verifying the edge cases. Now let's move to the practical demo in Android Studio to see this in action. Okay, now we will see the demo in the Android Studio. First, let us create a new project. Let us wait until the Gradle scripts sync with the application. Okay, yeah, now the syncing is completed. We can see the files that are separated in the folders. The manifest file, the resource file, and the Kotlin files. First, we'll create the user interface, which is present in the layout folder, the XML file. We will write the XML code to create the UI. Here by default, the constraint layout is given with a text view, and I'm going to clear all of this and use a linear layout since my layout just contains only single element. And yeah, since I have chosen the linear layout, I need to specify the orientation property, which is vertical here. And also, if we want, we can provide the background. So for a nice UI purpose, I'm giving a small background with a color code encoded in hexadecimal. And I am also defining the gravity property, sorry, not the layout gravity, just the gravity property to be the center so that all the elements are aligned to the center. These are the layout properties. Now we need to define the UI components. In our layout, we have only a single UI component that is the autocomplete text view. And I am setting to the layout width as match parent and the layout height as wrap content and assigning the ID. This is the most important thing for every component we need to specify. And quickly I'll give the properties of the component that I have mentioned before. Yeah, now we have completed the UI design with an autocomplete text view. Now we need to select this component in our Kotlin file. Now in the Kotlin file, we should write our core application logic, that is attaching the data to the autocomplete text view using adapters. The first step is to select the element that we have created in the XML file. For that, we need to create a variable um, and determine the data type of that variable and find it using the ID which we have given before. This is the first step. And the second step is to define our data items. That is the array list. So quickly I will, after defining the data, we need to create an adapter. So create our adapter type is an array adapter by passing the current class reference and passing the layout type that is Android dot r dot layout dot simple drop down item. How the elements should appear in the text box. After that, our array list. This is step 3. And step 4 is to attach this adapter to the text view. So simply take your autocomplete text view, use the method dot use the method set adapter and pass your adapter. This is step 4. So this is the final step, attaching a listener so that we can handle the click events. So I will write the code part and then I will explain you what this code snippet does. And yeah, now let's see what this part does. This attaches a listener to the autocomplete text view. It gets triggered whenever the user selects one of the suggested items from the dropdown. And this arguments part represents that the first underscore represents the parent adapter view, and the second represents the clicked view, and the position argument. This represents the index of the clicked item in the adapter, and the last underscore is the row ID. Since we don't use the unused parameters, we just replace them with the underscore. And we are selecting the city. Using the position, we will fetch the actual city from the adapter. For example, if a user picked Mumbai, this line stores Mumbai in the selected city. And this final line displays a short pop-up message called as toast on the screen. Example, if a user clicks Delhi, the app shows you selected Delhi. So in simple terms, this whole block says whenever the user clicks a suggestion, fetch that item from the list and show a confirmation message on the screen. Now we will run the app on the emulator to see how it looks. So here is the live demonstration of our app with an autocomplete text view showing some hints, enter the city name. So I have set the threshold limit to 2. So if I enter 2 characters, then only the suggestions will appear. So as you can see here, these are the suggestions from our dataset that I have provided. So if I select from this list, you can see at the bottom there is a toast menu that tells us which item has been selected. So in this way, we can use autocomplete text view to easily select an item based on suggestions. As we wrap up, let's quickly look at how this concept extends to the real world. Autocomplete is already a big part of our daily lives. For instance, search platforms like Google, YouTube, and e-commerce sites use it to provide instant suggestions, making searches faster and more accurate. In location services, apps like Google Maps and delivery platforms completely rely on this autocomplete to simplify address entry and improve accuracy. It is also widely used in contact input, where email and messaging apps save us time by quickly searching contacts as we type. Looking ahead, the future lies in AI integration. With machine learning powered predictions, voice input, and real time APIs, autocomplete will only get smarter and more personalized. So, the key takeaway here is the autocomplete text view, while simple, has a huge impact. It enhances user experience, reduces typing effort, and speeds up interactions across a variety of applications. And with that, we have reached to the end of the video. Thank you. And the codes that I have been used are in the description. You can download them from GitHub.